Hello, welcome back to Zero to Handmade Hero, where I'm going to learn how to create a game engine from scratch in C and C++. Um, Last time we kind of were getting to try and restart our engine function, and with no success, and we were kind of creating two windows, and wasn't really working. So kind of gone away from that idea. So I've done some stuff off stream and off video, just to kind of play around with a few things. So I'll walk you through kind of the changes that I kind of made. Um, so let's kind of start with Arena. So I have this memory chunk. I previously had that in the kind of the platform layer, I think it was, but I kind of like it to be included actually in the Arena. Um, so Arena is kind of this Arenum code is platform independent, and so when we are going to be using like a Linux, maybe if we want to do a different operating system, then this kind of makes sense. It doesn't need to sit in the platform layer. It kind of just needs to sit in the Arena and it could be used, and it kind of made sense because it's kind of like duplicating kind of the code. So the memory chunk kind of included the beginning pointer of the memory chunk and the size of the memory chunk, and then so did Arena. So I just kind of wanted to include it, and I made a bit of a few changes to my Arena. So I did have some to-do statements you might have seen in the last episodes about kind of popping kind of the last bit of memory off the stack with the Arena, but that also doesn't make too much sense because I'm adding this alignment. So I would have always kind of been like kind of bleeding memory because I wouldn't pop back before the alignment. So if I've moved the pointer forward like 32 bytes or 32 bits or 64 bits, then I wouldn't be able to get that memory back because I would have pushed the pointer. So popping it from the alignment, that alignment still would have existed. So I've kind of added this Arena save, which just returns the current offset of the Arena. And so we can kind of store that locally. So imagine, and we'll use this now actually when we'll kind of look at the file IO stuff, because that was kind of the idea. So we can return the current offset and then we kind of push to it. We push to our Arena and then we could be like, oh, okay, kind of something's gone wrong. Let's pop back to that offset. And if you see here, you just give it in a restore point. In fact, this doesn't, I need this to kind of, so we could say like, oh, this Arena, go back to this restore point. So it just checks if the restore point's less than the offset, less than or equal to offset, because we don't want to be like fast forwarding the Arena, that makes no sense. And just pushes the point back to the restore point. So that was one thing I looked at in my Arena. So going back to the kind of two window problem I was having, that was because I was trying to restart the window, but I think I was misunderstanding what these messages are kind of doing, and the order in which they kind of get called. So I've kind of added a few comments just to kind of remind myself. So what is the WM close message? So when I press like X or Alt F4 on the window, when the window's open, this message gets pushed to our message queue, the WM close one. And then when peak message sees that, it calls destroy window. And what destroy window will do is, close the window, and then we get this destroy window message push, which comes after the window has been destroyed. So when the window's been destroyed, then Windows sends WM destroyed to our message queue, and then we end up in this path, right? This code path, and we post the quit message. So we post the quit message onto the message stack. And then if you look at our pump message, it kind of just programmatically looks for WM quit. So after the window's been destroyed, then WM destroy gets called, and then which posts the quit message. So then peak message then sees WM quit and just returns 0 from it pump message, and then our engine stops. And so I think this was all kind of getting confusing with the restart thing. At the end of the day, I don't think I need to restart it. I think I'm just getting a bit too ahead of myself, getting lost in the weeds. This is me just trying to learn how kind of this stuff works. And I don't need to like kind of get lost in the weeds and the nuance of some of this stuff, you know. So I decided to go away from that. So as you can see, there is no longer a restart engine. Sorry, let me actually get help. I've actually got the engine code up. So now there is no longer a restart engine function. So as you can see with some of this commented out code, I did change some of the stuff. And that's because now memory chunk is now, like I said a second ago, is included in the arena itself. So what we do is we return, we get our memory. We ask the platform code for some heap memory. Cool, thank you. And then we split out into 2 memory chunks, and then we make our assets, arenas from these 2 memory chunks. So we have a asset arena and a permanent arena at the moment. We do kind of have to save this total memory. So this total memory chunk gets split up into 2 other memory chunks, per memory and asset memory, which creates arena. But if we wanted to free this, we still need to pass the points to the total memory. So we do have to save that to an engine. And those kind of things I kind of played with off stream. And let's see, give it compiles, which does, and then see, we get back to one singular window. Obviously the viewfinder stuff doesn't change because we have nothing called when WM size gets called, but anyway, and it closes fine, and we exit our program. So I think, yeah, like I said, I was getting down a bit of a wrong path with that. I'm gonna ignore that for now. The restart menu, the restart engine thing, don't think it really matters. Don't think it's really needed. It just in my head sounded like something that might be needed to kind of clear up the memory, but we'll just do the old-fashioned way by closing the program and starting it again. Okay, so I wanted to move on to kind of file IO stuff. And that is the platform being able to deal with file inputs and file outputs. That will kind of like lead into us being able to make a logger, hopefully be able to like debug stuff a bit better. I have looked over some stuff in my own time, and hopefully I can write something that inputs files, and also that'll be how we would read in like assets. So if we have textures on disk that we want to write, that we want to read, or shaders is another one. So yeah, so I think we'll kind of get going with that stuff. So in my head, we need a new kind of struct now, that I'm going to call file data. And what this is going to be is we kind of want like a pointer to the kind of start of the yeah, so we want to point it to the start of the file, and I guess the size of the file, so how many bytes there are. Does that kind of make sense? But now how big should that be? Should that be 32? Should be 32 bits or 64 bits? I think U32 ends up being a few gigabytes. So for now we'll have it as U32, and now we want to update our platform API, right? So now our platform needs to be able to have a function, right, that reads a file and returns a file data struct that contains a pointer to the beginning of our file and the size of it. So we should be able to use that size to kind of read the along the data. So what do we kind of need to pass this function? Well, we're going to need some. Do I use a const? We're going to need some. We're using wide characters. WCHAR pointer. Right. So this is the path. So this is path on disk where this file is that we want to read, and we probably want to save it to our arena. So our arena, you know, we have kind of two. We have our permanent memory, which might include shaders, but maybe the other one, the assets arena, maybe that only wants to have assets for a certain level or a certain thing that we're kind of reading in the moment. Is the idea. Okay. So that's kind of, so here we're in our Win32 platform. Okay. So that's file data, Win32, read file, and we want to input a const wchar and what was it for our arena pointer? Okay. So what does that look like? Alright, that's definitely not how you do it. My my Vim skills is, I mean, I'm learning a few shortcuts and stuff, but it's definitely lacking to be, to say the least, because now that's kind of loads of white space at the bottom of this file. But anyway, right, so file data in 32, read file. Jesus, path, arena pointer. Let's actually keep with our formatting. Okay, so what do we kind of need? So as you see, I've got this read file function up, but we kind of need, as you can see, so the H file first input is a handle. So we're going to need a handle to our file. So it looks like we use this now to be aware that's create file ASCII, and we are trying to stay wide, so create file wide is what we'll probably need. And what does that return? So that returns a handle I know this is create file, but it's not actually creating file, it's creating a file handle. And so what does this need? So long pointer to a const star string is the file name. So that is going to be our path, I think. D word desired access. The request access to the file or device, which can be summarized as read, write, or both. So we are obviously not writing. We are reading this file. This is a read file function. So we want to give this a generic read access. Share mode. the requested sharing mode of the file or device, which can be read, write, both, delete all those. If this parameter is 0 and create file succeeds, the file device cannot be shared. I don't necessarily. Let's have a look. Enable subsequent open operations on a file or device. Right, I'm not sure, but we're gonna share the read. I think that means other things can read from it. Not 100% sure. LP security attribute is pointing to a security attribute structure that contains two separate but related data members. This parameter can be null. Fine, it's going to be null. Create disposition, an action to take on a file device that exists or does not exist. So we don't want to always create a new file. We don't want to create it if it doesn't exist. We only want to open it if it exists, right? So we will set this to open existing. I think. Word flags and attributes. This the file or device attributes and flags. Vatrum being the most common default. Well, if it's the most common default, then it will be what I'll be using. I will say one thing about the Windows 2 API is all these like flags to set. Don't go enough in detail about what they do because there are so many to do. So I just kind of follow the kind of default pathing or just null it if possible. Interesting. Okay, the file does not have any attributes set. Oh, so sets it. Okay, so sets the attributes. Fine. Right. Okay. Okay. Parameter can be null. Right. We're gonna set this to null. Okay. So this should create a handle to our file. I guess then we want to make sure we've returned. Where is the return type? This handle should. It's probably nullable. Yeah, no, I just remember now. We got to use close handle at the end as well. No. I'm sure it can return. Not 100% sure though. Right, we're going to just make a wild guess and see if it returns 0. Because I'm sure that is kind of what it is. So basically this will mean, I hope, I'll find this, but I can't find it right now, that file handle has returned some error code 0. That means file doesn't exist, I guess. Wait, actually, I guess it would be part of open existing, wouldn't it? Last error code set to 2. Right, anyway. We'll leave it in just for some idea that we've kind of tried to deal with it returning 0. Now what do we need? Well, we want to push, so basically on our arena, because we're passing our arena, and that's where we're going to store this file. We want basically the struct of the file data, like kind of then followed by the actual bytes, right? But anyway, we need to push to our arena. We need to ask for a new file data pointer. From our arena. So that looks like this. So our arena push gives us a null pointer. We cast that to a file data pointer. We want to push it onto this arena and right, its size of the file data structure and then default alignment, right? Okay, so now we have our file object. We have a handle to a valid file that exists on disk, and we have file data to be able to start reading it into. The way I've seen people do it is they then read the file into this large integer structure. I guess this is a union. Yeah. A union of structs, and I guess it kind of holds an upper and lower word. If your file has a built-in store for 61, use the quad parameter store. Right. I guess it's so if compilers. So I guess if it's in 32 bits, then it just will store to the low half of the word in the first 32 bits, and then have 32 separate bits for the high part, and I guess you have to compile it together, like push it together. Whereas if it's 64-bit, which we are running 64-bit, so I guess we just use the quad bar. Anyway. Yeah. So this is the file size. So this is how big the file is. I'm gonna zero it because I zero all my structs, but maybe that's wrong. Yeah. Don't know where that came from. Okay. So we need to okay. So we have the file size in this large integer struct, right? Which there's definition again. Right, so it looks like this compiles differently if this window was set. So I guess if it's not, if you're running in like maybe 32 bits, then it becomes a union, and if not, it's just a struct that contains quad part, which is defined as a long, which is U64, right? Oh. Sure. So we need to get the file size. So is it gonna just be get file size? It's recommended use get file size extended. Yeah, so it takes in a large integer and you give it a handle to a file and it returns a boolean. So I guess if it's going to return a boolean, we can, I think I've seen people wrap it in an if, and so they say if get file size of our file, because that's a handle, and read it into file size. Oh, unless it doesn't exist. This is a handle. Oh no, sorry, file handle. It doesn't. If the reason it doesn't exist because it can't find a signature with a file data, you know, just trying to overload the function. Right, that's right. Right. As you can see here, it says p large integer, so it wants a pointer. So yeah, there you go. And I guess we want to say I guess we want to handle if it doesn't. So let's say because I guess if this fails, right, then we want to okay. What do we want to do if it fails? Well, we're going to return 0. That's just what we're doing, kind of returning an null pointer. I think before we had that, I said earlier we have the handle. So we want to close this handle, right? We have this close handle function, and it takes and close handle, and you pass it the handle. Fine. But then here, you see here we've pushed to our arena. If this now fails, this this file data struct is pushed onto our arena and just empty, do nothing. So this is why I wanted to do this restore point, right? Where like if we look back at our arena here, we have an arena save and we pass in our arena. Okay, so what this has done is this read our current offset in this arena. We have now pushed on into this arena, so we've kind of moved the pointer along size of file data. And if that's failed though, we now don't want to return, because that kind of arena is almost like what's the word I'm looking for? Kind of bloated with a file, you know, some file data that we're never going to use. So now we can do arena restore arena okay. So now we kind of push we've kind of popped that file off our kind of stack, right? Okay. So if we don't go down that code path, then it succeeded. So we then want to read. So file size now should contain, right, our file size, our actual file size. Let's go back to so we have this quad part here, right? So in our file size, in this integer here, we have the size of our file. And we want to store that in this file data structure here. So file size is going to be equal to, and we'll cast it as a U32 because I think it wants to be a U32 in size. It does. I guess long is 64 though, so I'm kind of casting it down, so maybe that's wrong. Anyway, 32 being still pretty big, so currently we'll leave it at that, and I will add to do is this big enough. Okay, so read that into our file size structure. Makes sense. We now want, so yeah, so file, this file struct here for file data contains the pointer to the beginning of our data, but we have to still put our data on to the arena, right? So we need to push it again. This time, we just want a char pointer, right? So how's that gonna look? Um, well, I guess we want to. So we want to allocate this much size on our arena, right? So file, what do I call it? File bytes. So file bytes. We want this to point to our arena, right? So we then can arena push. Onto the same arena, and then we want to push this much data on. I think like that makes sense. Now, one thing I'm a bit confused about is kind of when you read bytes, they're normally null terminated. So the final character is going to be a null byte terminator, and that's to say like, oh, this is the end. And so that's how like kind of C deals with strings. And so like the size of, if you read in like a string for like with 5 letters, the size of things actually going to be 6 characters because it's going to include the null byte. So I'm not 100% sure, but I think we want 1 extra space because I think when we read in this file, this might not include a null terminator. So problems we might run into is if you pass in like C style strings to, let's say we're trying to have a shader, if we, the program might not know when that shader ends if we don't have a null terminator. So we might need an extra space for it. Oh, excuse me. Yeah, because it's going to be like, we're going to ask, oh, what's the size of our file? And it's going to be like, oh, it's 64 bytes. But then we want to, when we read it, we might get a null, add a null byte to it, and so far we might need 1 more byte of space. So now we want to, right, now we want to read a file. Because you think this is our buffer, so this is going to be our buffer here, where to read the data to, right? So we've allocated enough space on our arena to write our file to. I think, yeah, I think that's okay. Well, what does it mean? Okay. Well, it returns a bool, which I think is just a thing of an int. File read. So we want to read this file now. So I'm going to pass in the handle. Right, so that's our file handle. Our buffer is going to be of file bytes. Number of bytes to read is our file size. Right, so this is why. So we need to append that one there, because now we wouldn't read that null byte. We would terminate the file before it's finished. Number of bytes. I don't know what this number of bytes read is. Number of bytes read. A pointer to the variable that receives the number of bytes. A pointer to the variable that receives the number of bytes read when using a synchronous parameter. Well, currently it's synchronous. I don't want to set it to null just yet. Because it was a pointer to a D word, so I create a D word, set a 0, give a pointer to it, can read bytes into that. Overlap. Pointer to an overlap structure is required if the HTML parameter was opened. Otherwise, it can be null. So I think for our thing, it's going to be null. So we have read the file now into our buffer that we have set on Arena. Right. I guess we want to make sure that the amount of bytes read is equal to, okay, so we can say, so number so we can say correct size equals right, bytes read, and is that the same as now, does that need to be appended with a 1? I'm not sure. That I'm not sure of. So that here we can do the same thing, right? So you see we've kind of pushed again to our arena. If either of these get messed up, then we can go back to our restore point again, right? So we can say if file read, because that's going to return a 1 if the file's read correctly. And correct size will be 1 if if we've read the right amount of files. So let's say we can say right, is that right? So if file read comes back that we've read the file. Yeah. So basically this is zero. I've kept myself confused. So file read has come back fine. And if correct size come back fine. Yeah, so invert that, and then we want to do the same thing. So this is wrong now. So we want to just restore back to the beginning. Let's pretend like this never happened. For our arena. And then what did we call it? Restore point. We can return 0. But I guess after we've read it, we don't need. We have to close the handle anyway, right? Even if it's correct or not correct. So if you remember here, oh, it's not called handle, is it? It's called file handle. Up here, we closed the handle fine because it went wrong. But we've had the handle open, we've read the files out of the handle, read the bytes out of the handle. We've done everything now. We don't need it, correct or incorrect, we don't need the handle anymore. So let's just close the handle here. Let's double check we've read if we've read the right amount. Now what do we need to do? So we just return the file. I just want to double check this thing. Like this is, I wish I had an example. Okay, well, we've been going for quite a while, so let's just kind of read over what we've done. So we kind of wanted to add another platform layer to be able to read a file. Obviously, that has to be a part of the platform layer because this is going to be different. So, it's different syscalls if we're running on Linux to Windows. Obviously, we're only kind of really ever probably going to do Windows for now, but we want to just do this the proper way. So this is how we'd read a file into our arena. Excuse me. And what we've done is we've got some space on our arena to read the bytes into. We then have a file data structure which contains the points to the first character of the data and the size, and then we can return that, and then sorry, excuse me, I got hiccups. The user can do whatever it wants with that. I need to just double check this because I know C style strings are null byted, but does that include file? Do I need to do this myself and append it myself, or anyway? Because I think I've definitely seen people plus this one for the size when it comes to reading bytes from files, but anyway, I think that's a good place to stop. Yeah, right. Thanks very much.